it installed, you can just follow along. I record this as well. I think Courtney just told me that when she signed in, she got the IT version and not the web version. So the IT version, I'm talking about the VDI. The IT version does not have all the tools that we have in this class. So if you don't have the one that says IT web student, then that's the wrong VDI. But I already submit all your names in there, so it may take a while if you don't see it. I also make a note as well to let them know that just to make sure you have the access to the correct VDI. Okay. So let's look at this note for a second here. I'm now gonna go to every very detail, but it just basically talks about what a database is, right? It's a group. You have like three different or two different versions or definitions here. A group of constructs include at least a set of table objects, more often than not other objects as well, and a store such as a procedure is an object. If you, it's kind of hard to really conceive that in your mind, but it's a procedure, it's a function as well. A view is something we'll also cover in the later chapters. A view is almost like a it's like a what do you call it? A virtual table of some sort, and then let's store a group of data in terms of tables. So that's like from the textbook. And a simple term will be a collection of data or information, right? Stored in a computer system, provide retrieval and manipulation. That's the basic or the general term for a database. So don't confuse the word database with the database system. That's two completely different things. Okay, so because database is so popular, we sometimes use the word what database do you use? Okay, well really we should say what database systems do you use? Okay, because the system is a server is different than a database. A database itself is just a file name. Okay, so so a database systems or a DBMS. A relational database would be RDBMS. You see these acronyms a lot in database world. The RDBMS or just DBMS is what's called a relational. Relational because the data are related somehow, right? So you talk about tables. A table, if you think of a table, is a two-dimensional, it's like a two-dimensional array in a program that you write, right? You have a table is made up of rows and columns. Okay, so the column itself, each column, if you think in Excel, would actually what we call a description of the table, right? It describes that table. So if you think of that table itself is in terms of like object-oriented programming, it's like a class, a template of some object, right? So a table, usually you don't have a table of many different stuff. A table usually is comprised of many attributes that describe one particular object, like a table of students, right? I have 8 of you guys in here, and each of you is an instance of the table, student, and each of you have different attributes, have unique attributes, but we all have similar attributes. You have, eyes and ears and arms and legs, right? So those are attributes. We talk, we move, and then we breathe, and we do all this stuff. These are attributes that describe you. So each attribute is a column in the table, okay? And then each row is one instance of that table. So each row represents one of you guys, right? So each student is a row, okay? So just want to make sure we have a clear understanding of these terminologies when we say a record, right? A record is a row, is an instance of that table, okay? So when you write programming, same thing. You have an object of a class called student. When we say student 1 is equal to new student, that is one row of record or data, right? So that's what it is. And then the columns will describe what that object is. So the table is also what's known as an entity. Okay, an entity is what? It's a thing, right? You can think of it as a noun. It's an object of some sorts of thing. So usually, when you create a table in a database, it usually represents a noun. not in action but in noun, right? Of some sort. Those nouns could be physical things like a car or something like that, or it could be a process too, right? So that's in a, I guess in a nutshell, that's what a table is. Okay, it's the entity of some sort. And later on, we learn about how we can design databases. When we talk about how do you design tables, then you have to really break it down into really it's very very specific entities. Okay, you don't want to mix a lot of things together in a table. It's not really efficient. We'll talk about that in, I think, like Unit 5 when we discuss normalization. It's a really important process in database design. Okay, so so the word relational is the key here, because these tables are related. So so each table should be about one topic or one subject only, student, and then you have other tables that may relate to a student, right? A student take a class, so you have another table of classes, and then you have another table of schools, another table of, I guess, addresses or home, whatever that is, and they're all related to that student. And then how do you relate them together is by using a key, right? So you have the primary key, you have the foreign key, and you connect those tables together through those keys. A key is basically just a unique ID, right? So so that you can have multiple tables all over the database space, but they're connected together based on their relationship. Okay, so you could have, we'll talk about this later on, we'll talk about the many types of relationships we have in a database tables. So you have one-to-one, one-to-many, and so on. Okay. So relational database, and then we have the components. These are just some many other objects or components, usually just programs that are work together to, I guess, to allow a user or a programmer to build databases. So we have the engine itself. You need that. This is the SQL Server engine. We need the tool to allow us to build the database. Okay, so like the SSMS is one of them, and there are many others as well. If you're using Mac, Mac has a different one called SQL Operation Studio, also very, very popular. There's another one called SQL Client something. It's a paid version, but they have similar items, tools. And then we have the agent. Yeah, there are many more. There's just some of them. Agents is a scheduling system that runs in the background that maintains your server, right? So if you make changes to the system, it would do that. If you have some type of automation like backup systems, the agent is responsible for doing all of those stuff. Okay, so there are many more, but it's just a few of them. And we have 3 different versions in here. We have the standard edition. We have the Express, which is a really light version, which is good enough for us to use. And you have the standard version. You have the BI, which is stand for what? Business intelligence, right? Or the analytical analysis version. And you have the enterprise. This is a full enterprise version. So you have different editions. So just talk about some sizes of the database. Sometimes we like to think that a database has like an unlimited size, which can kind of be true, because if you keep adding data to it, right, you keep adding memory, you pretty much end up with an unlimited size. So if you think about like, I don't know what, YouTube. I mean, imagine the size of that database to store all these millions of videos and audio. That's a lot of data. But of course, it's not going to be stored in a relational database. It's stored in an object base, which is a completely different database. It's much, much bigger than SQL Server in terms of data size and how they store this data. So it's beyond the scope of this class. But you have those type of data. Just tell you what you need to install. So I'm gonna go have a web version too for like Azure and things like that, right? And on the cloud, yeah, the Azure. So tools. So just talk about some sizes of the database. Sometimes we like to think that a database has like an unlimited size, which can kind of be true, because if you keep adding data to it, right, you keep adding memory, you pretty much end up with an unlimited size. So if you think about like, I don't know what, YouTube. I mean, imagine the size of that database to store all these millions of videos and audio. That's a lot of data. But of course, it's not going to be stored in a relational database. It's much, much bigger than SQL Server. here. So objects in here is just a list of some objects. When say DB objects, so all these are objects in database. Okay, so you have the database itself is an object, right? So Eventual Works 2014, 2016 is an object. The transaction log is an object, although it's just a data that stores every action that you perform on the server, like every SQL statement you perform, any error logs, it logs everything, it tracks everything. You use that for well, debugging purposes, or if you have a system that crashed, you can always go back and find out what happens in that log. So it's really important to have that log. You have tables, indexes, we'll talk about this later. You have file groups, diagrams, views, and so on. Okay, these may not, sound familiar to you now, but I think after you complete this course, I guarantee you, you know what this means. Okay, and why they're important. Okay, especially the table indexes, diagram views, and stored procedures. These right here will be stuck with you because it's very similar across all databases. Very similar. So in the SQL Server, you have 4 system databases. These are called master, model, MSDB, and TempDB. And these come with the server, so you cannot delete those. Okay, if you try to delete them, it will say you can't. Okay, you need those to run the system. If you happen to miss one of those, it's not there. That would be very rare, but you should have all those 4 in there. So just to show you what that look like right here, if you go into the system databases right here, you see that those 4 of them here: the master, the model, the MSDB, and you have the TempDB. Each of those have its own purpose. It serves a very specific purpose. So the master, you can kind of know what that is, right? Is the master of all the databases. Without that, you cannot have this system. Okay, so it stores everything in there. The model here is used for usually, let's just say, if you want to create a model, a database, so that every time you create a new database, it would follow that blueprint. You can go in and set up a new model. So okay, every time when I create a new database, I want this much memory in there. I want to have this maximum capacity. I want to have this type of, there's a whole list of functionality that you can modify, so that so that every time when you create new database, it will use the model instead. So we're now using just the default, whatever is built into the model inside the studio here. Okay, so you can do that. This is used by something else, mostly some of the agents, and this is a TempDB. It's really hard to kind of explain what these are, but the TempDB is used as a temp location to run your databases. So every time you create a database, a table, you run it, it actually creates a copy of that in the TempDB. It runs that, and then of course it deletes it itself. It's like so that's why it's just temporary. It doesn't stay there. Once you log out, you go back in there, the whole database in the TempDB is wiped out and it's refreshed again. Okay, so so those 4 are the system databases, and then any databases you create will be listed under the databases tab here. Okay, so we have only 1 here because we installed that in there. Okay, so those are your 4 databases. Here I kind of put some notes in here to kind of tell what each of those is used for. So the tables, again, if you want to refer back to the assignment, I kind of have the definitions here already, so you can come in and grab these. It's fine, right? Information about what they are. Index, we'll talk about this later. Okay, index is just basically an object that allows you to sort your data in a more efficient way. Okay, so when you create a table, it automatically has an index built into it. Okay, even though you create one, it has one, just so that your data can be easily searched and so on, right? So you use the index to sort your data in a certain fashion. So when you search for a certain name or a certain number, it knows exactly where to go. Otherwise, it would have to go from the top all the way to the bottom. And the worst case of that is, you go through every record. If you have a million records, it's going to search all the way down to the bottom to find it. And so when you sort it, then it's much easier. If it's in the top 10 or the top 100, it will find it. It's right there, right? And imagine if it's not sorted and you randomly, pick somewhere in the middle of that table or the record table, right? How do you know which direction to go? So index deals with that, and there's some pros and cons with that as well. We'll talk about that later. A trigger is something else. It's another object or another program or like a function you can write, and a trigger will actually get triggered. It's like a trigger. You're just waiting for something to happen. So for example, if you put a trigger in the code, and so that every time when somebody updates a table, it triggers that code and it does something in the background. Okay, so that's what it is. We'll learn some of those later. Constraints here is also very important. Constraint is just like it is. Every table should have some limitations to whether or not it should contain certain type of data, right? So you put some constraints on those tables. So for example, a table will have a column of data, and that column can only be contain only numbers, right? Or maybe if it contains numbers, but only between numbers between 1 and 10. Anything outside of that scope is not allowed in there, so you put a constraint in there as well. Not only that, you can use the keys, the foreign key and the primary key, to link two tables together. So therefore, you link those two tables together, and so therefore you cannot just delete one table and leaving the other one kind of like fragmented, right? So that doesn't work. So it doesn't allow you to delete a table. If you want to do that, you have to know how to do it. Otherwise, it won't work, right? So because one is dependent on the other, so you have to make sure you delete the correct table first before you delete the other one. So I mean, just some of those are really good because it helps you to safeguard your data, to contain your data. Sometimes if you don't do that and you accidentally delete a table and then all the data is gone, and then you're done because there's no undo. Okay, there's no undo in the command there. Okay, so if you want to back, you have to go back to the log and find out if you have a copy restored somewhere. Okay. Diagrams, the ERD, or it's called the entity relationship diagram. This is it's like a physical representation of all the tables and the diagram, kind of show you how they're related. So for example, in here, if I look into this diagram here, this studio, you can see it has a lot of tables in here. All these are tables, okay? And if I want to see what these tables look like and how they're related, if I click on the Adventures Work database, I do a right click. No, not right click, right here. I mean, the diagrams here. Yeah, you can do a right click or you double click it. If I say new database diagram and just say yes, hopefully that will. Did I miss something? Okay, I have some problems in here. But usually, if you do that, it would show a diagram of all your tables connected together. What doesn't it do here? Yeah, I have to figure out why it's not working there. I have some permission issue. But you see a diagram that look, maybe it's in the book. No, one of the assignments has it. Just want to show you what that looks like. Let's see. Maybe. So in here, for example, let's see if it's in here. Yeah, well, it looks something like this. Okay, so you can see that it has what, 7 tables, and each of those tables has some type of key. Okay, you can see that 4 of these tables here, files are connected together to an out, right? So they are connected. You can see the relationship between those 2 tables here. So all these are connected together by a key, and the key is this yellow key here, right? Plus, on the other hand, you see something look like a number 8, or the infinity symbol, right? It just means the type of relationship between those 2 tables. You have what's called a one to many, because the many, infinity means many. We'll talk about those means. But the ERD will give you this diagram here, and so you can look at this. You can, of course, drag this around if you want. So when you look at this, you can say, oh, okay, I can see their relationship, and I can see that, these 2 tables are connected, like the vendors and the invoices are connected. How do I know? Because look at the key, right? So you look at that key here, it's a vendor ID, and here also has something called vendor ID. So they're connected by that key. So one of those keys is a foreign key, one is a primary key, and we'll talk about how they are related. So in that way, that's where you see the line connected to it. Okay. So if they're not connected, then they don't have that relationship. Okay. So that's what it means when it says you can use the RD to do that design. You can use that as well to design your database physically that way, and then it would do it automatically in the code for you too. Virtual tables, again, views a virtual table. We'll look about that later. Store procedures, or something called sprocs. Some people call it sprocs, just for short. So those are just like a function or a procedure. A user-defined function, something called UDF. You can write your own function as well. And data type, there's a lot of them. There's a lot of data type in SQL Server. We'll look at those later. Variable names, just like any programming language, you have variables. These are the actual identifiers itself, right? You can have that's why we have a table called student. It's the word student is the variable name. You cannot have duplicates, right? You cannot have 2 table names student. It's not going to be allowed. It should be unique. So you can have variable names for all these objects here. So you have a procedure, you can call it, get, display total or something. You can have a table name. You have table has a column. Column has its own unique name. Again, a view is just a virtual table, has a unique name, and so on. So all these have names. Okay, when you create something using these keywords, you will have to use a name and lots of variable names. And then these are the rules to create variable names. So each language, each program has its own. And SQL Server is probably one of those kind of the weird ones, because you can have some really strange names in here. And it's allowed. That's pretty cool. You can have spaces, and if you want, you can have you can use the same keyword in here. Like if you want to use the keyword table in there, that's fine too. You just have to wrap it with the square brackets or the double quotes and so on. So we'll do some of these later as well, how you can define variable names. And then I show you some examples in here. For example, the word create is a keyword. So usually you cannot use a keyword as a table name, but if you wrap it with the double quotes, then it's okay, right? Or if you wrap it with a square brackets, then it's allowed inside SQL Server. So if you notice, again, table is a keyword. Same thing with use, right? These are all keywords. So usually you cannot use that in other languages. Like try that in Java, and I wish you good luck. Okay, they won't let you do it. So some flexibility there. It's pretty cool. Okay, so this is a really brief note about some of these different objects in the database. Okay. Let's see. In the first chapter, so you just basically, if you want to read the entire book on the entire chapter, that's fine. But I only require you to read chapter 1 in the section here from page 1 through 21. These are just the rest of the chapter 1 here. It talks about many other features that we will explore later. So it's like it gives you a brief overview of what's coming up. So don't expect to know everything in chapter 1. I mean, the author puts everything here. All these store procedures, all the views, indexes, everything's in here already. All the different ways how you can use to connect to a database. This part here, for example, this is where you would use to connect, from Visual Studio or Java or Visual Basic or any other language. How do you connect to this database? So he shows you this diagram. I'm pretty sure you're kind of familiar with this already. Again, we talk about different tiers, right? So you connect to a database using the ADO.NET and many other ways. So we're not going to do any of this stuff in this class, okay? This is for if you want to develop an application that uses this database, then this is how you set it up. But we're just focused on the database itself, the server itself, and how do you build a database and how do you populate and build those tables, okay? So this part is not going to be covered. So again, back here, so feel free to read through it, but I just want to require you to 1 through 21. And again, just the history of SQL, a comparison with other systems. Oracle and DB2, these are two other big ones, and MySQL, open source. So nothing much going on here. Okay, so here, if you want to read through pages 22 through 30, it shows you some examples of how you can do queries. So you may not understand why they're created the way they are, but it's going to give you an overview of what's coming up in future chapters. So we don't really get into writing code until I think chapter 2 and chapter 3. Okay, so but before you leave today, I just want to show you very quick how you can do that in the studio here. And well, first of all, let me see if I can have access to even run a statement in here. If I can't, then it's not good. Let's see. Okay, so I just really quickly show you a quick way how I retrieve data from this table called person.address. Okay, but I think it's kind of hard to see. Hopefully you can see, but I want to show you what these are. So you see that inside here you have something called the DBO, a table name DBO.aw build version, right? And then down here we have something human resources department, human resources employee, and so on. So it's a dot something, and these are again object. So this is what we call a schema, right? A schema is just a way of how we organize data. So imagine you don't do that. You're going to have all these tables in here, and you can see there's a lot of tables in here, and some of these are actually duplicates, right? So with a schema like a person dot something, I can organize all the entity that are related to the person or belonging to this person group, right? I can put all the tables that are related to human resources under the human resources group. Okay, so I can have human resources department. I could have, another just a production department, because it belongs to a different department or different schema, different group. I can have a duplicate table name. Okay, so when you reference that, you have to reference the actual schema or the group the table. Okay, so without that, you are limited to just one department, right? So you have that limitation. By doing this way, you can use many more. So to access or to get data out of these tables here, and in this studio, I'm going to go ahead and close this. So once you are in here, you want to make sure that you are using this VentureWorks database. If you create a new one, just make sure you also select that. And then to use the query, you go up here and it says there's a button here that says New Query. Okay, you click on that, and you're presented with the new screen here. This is where you put your script. Okay, so you can actually save this. Once you do your script, you can save it, and then you can save this as a .SQL text file on your machine somewhere, and you can always, open it up and use it again. Up here, you also want to make sure that in this drop down here, you want to make sure you are selecting the correct database to use. Okay, if I happen to choose the master, and I'm trying to retrieve some data from the adventures book here, it's not going to work, right? So, for example, if I want to show all the records inside the person table right here, so I could say, so the command will be just to view. If you reach up to, it will tell you. This is the simplest statements, not simplest, but one of the simplest. You can say select. Okay, select is the keyword. This is to retrieve data. Select space, and then the special key code here is the star, which is the wild card to select everything. Okay, that's everything, every record, every column in there, and then from what, right? From the person. So it has this intelligence to help you. If you type person, and then it will say person, and then you put a dot. So just basically reference this table here, person.person, okay, person.person, and then
because you have the master selected.
Right.
Or you use their use eventual words.
Mm-hmm. Right. So if you do this, right, so Steve just mentioned that, right, it's because I'm using the master, and it says, oh, there's no person.person in the master's database. So if you go in here, right, the master, there's no table in here called, or even view called person.person. So just make sure you are in the right database. So I have to select the Microsoft, which work like that. Okay, if you don't do that, then like Steve said, you have to use the word use, and then use what? Use the adventure works database. Okay, 2012.
14.
Oh, is it 14?
Yeah.
Oh yeah, there you go. Okay, so once I do that, then okay, it's gonna use that from that. I usually put the word go here too, but so now it's okay, it's happy. So this intelligence is gonna help you to make sure you don't make any mistakes. If you put an S in here, you notice that there's no such thing as persons either. So it will tell you with a red squiggly line, very similar to Visual Studio, right? So now to run the script, if you use this way, then it doesn't matter what I select here, right? It doesn't matter, because this is going to override that completely. Okay, it's going to select this database, and then from this database I can run here. And to run it, you just go here and click the exclamation mark or the execute. Okay, if you click on it, and it will run with accuracy very quick, and the result usually displayed down here. You can move this up and down. Okay, show you. And it tells you right on the bottom right, I have about 19,972 rows or records. Okay, in this table. So you can scroll down. You can see that all the way to the bottom. Okay, if you expand this row here, you see that it's 19,972 records. Okay, that's everything in that table. Everything, including all the columns and any additional object columns that is automatically designed, provided by the system. So this row GUID is another unique ID number, just used automatically by the system to make sure the table is unique. If you happen to, transfer this table database to a different system, so that number is still unique. That's all. All right, and if you want to close this window down here, if you notice there's no way to close it, and the shortcut to do that is just you press the Control R, right, on and off will display and then remove the results down there, because sometimes you run out of space. Okay, when it does happen, just press Control R to remove it. Okay, so that if you use this, if you don't use this one here, then you want to make sure you select the correct database here. And if you do that, then you still get the same result. Okay. So if I go back here, you can also do this. Let's just say I'm back to a master, right? And I run it. It should still work. It's the same I did earlier, because it will run from top to bottom. Okay, so in here, if I have a lot of code, you don't have to run everything, because later on you're going to have maybe 10, 20, or 30 lines of code. You can pick and choose each of those lines and run it separately. So example here, I could select line 4 and run it, and so it will just run that line. So for example, if I put the same code here, let's just say select from the person dot address table, right? I have 2 of them. If I run it now, you see that I present with 2 different output. So the top one is the first line, all the 19,000 are here. The second is from the second table, all here. If you do multiple selections, you have a lot of results down here. If I just want to, oh, you know what, I just want to run the second part, you can highlight that, and you can click execute. It will only run that. But only if you select the correct database, right? If you happen to do this, right, and if you run it, it's going to have an error, because it doesn't know where it comes from. It expects to go here and then run this code, so it's not going to use this database, so therefore it's not found. So just want to make sure you select the correct database, and that's why it's always useful to make sure you select that here, so you don't have to worry about using the command here. This is only very useful for if you write the script itself, and you want to pass the script along to other people to use it, to install it, and then you will, this is like guaranteed it's using the correct database. Okay, so I can pick and choose. So now I can choose, oh, just run that line, select that, execute, and so on. Okay, so the star just means everything. If you notice over here, you can also go over here and do a right click on any of these tables here. Okay, if I just say the this one here, the human resources job candidate, and if you do a right click, it gives you some of these options here. You can quickly just say select the top 1,000 rows, right? If you do that, it will run and it will give you the 1,000 rows if there are that many, up to 1,000 row records. If there's none, it will pull everything. And not only that, it also gives you the actual statements to run that as well. You can see here. And it has a lot more information than what I just wrote, right? And this one here, it grabs everything. It grabs the 1,000, the top 1,000, that's what it means. It grabs the job candidate ID, that's this column here. So 1, 2, 3, 4 columns. So you have 1, 2, 3, 4 columns from the human resources candidate. And this is the actual database itself. So you have the database name dot the department or the group dot the actual table. You can actually go beyond some more over here on the right side. You can have the server name dot adventures work. Okay, or you have the IP address if you want to grab that from a different machine, a different server. You can say IP address or the server name dot the database name dot something. But since you're already here in the same location, you could basically omit all these here and just grab from that human resources. And if you want to grab everything, just say I want to grab everything. I don't want to list them all. Just put a star here, right? You can do that. Give the top 1,000 or top 10, top 100 from this table, and it should still do that as well. Okay? So, I mean, we'll learn some of these later on. I was kind of walking really fast, but just to show you the difference between this different schema. If I take this out, okay, it does not know what table this belongs to, right? So that's why we have to specify the schema, the group, and then dot something. So you need to call that's a full qualification to to grab the table. This is, and I think some of the examples that we're not going to be doing like this complex, like person, that something. You can do that, but it's just basically be really easy. The DBO, which is the database object itself, and that's automatically generated, and for us. Okay, so back here, so this is one of the simplest statements. Select star from the table name. Okay. So if you want to select not all 19,000, you just want to put the top 10. Then you can, so you can put the top 10. You can just do that, or you can wrap this with a paren also. So now it only runs, it shows me the top 10. Okay, it doesn't give you the rest anymore. So the top 10, based on the way is sorted by default. So in this case, it's sorted by the business entity ID. Okay, and you can do a lot more. You can say, oh, just show me the top 10, but in reverse order, or the top 10, but only those who have a certain title. So you can do all those stuff. We can do that later. Okay, so. That's the select, and this is probably one of the most widely used command in all databases, because all we do is basically retrieve data. Okay, select. So when you say select, retrieve, or get, this is what you will use. Okay, so that's why the book actually, I think the book dedicates like 2 or 3 chapters just for the select itself, because we have this much data. Really, it means very little to you if you don't know how to retrieve this data, right? How to retrieve it. Now, I have this many table here. Well, how do you get give it the person who lives in this country, that belongs in this department, right? And is between the age of something and has a production of what? How do you do that, right? So you have 5 or 6 different tables to call from.
Imagine having to write a program that does that.
Yeah, right. So you'll be doing that using the select statement. This is very, very powerful program to do that, the SQL statements. Okay? And we'll do that I think in chapter 3. We'll do the joins. You can join tables, multiple tables. And it can get confusing, but also quite interesting. Okay? So let's see. Anything else I want to cover in here? So the first 2 weeks or 3 weeks, we'll be just using the select statement. Okay, we're not going to do any creation until maybe the 4th week or so. Okay, when we create tables, so I want to make sure that you know how to select, get data first. You're comfortable with that, then we'll go and then do some table creation or database creation, and then you can do the insert, the update, and then the delete, and then you can also, once you have a table created, usually it's really hard to go back and make some changes, especially if your table already has data. Okay, so it becomes really important when you design your database. Okay, when you have a table that have like 1 million records in there, like this one here, and you suddenly see, you know what? I want to change one of these table columns to something, right? You can't easily do that because you run into some type of conflict, okay? And maybe because the table has a different data type, you cannot just change it to a different data type and expect it to work. So how do you do that? Well, after you wipe out the entire table and design everything from scratch again. So that's a nightmare. So that's why when you design your table, you have to really kind of think, into the future, whether or not you want to make any changes at all. If you don't, then, you can go ahead and then, use that in production. Otherwise, you want to design it in a very, very nice fashion. Again, that's the process of normalization and stuff. We'll learn that later. And then how do you connect these tables together too, right? So that's also really important. So the select statement, I think that's all I want to cover now. And so if you want to read chapter 2, okay, for next week, and then next when we come, we'll dive deeper into the select statements, and we'll do some of the where clause, the order, how do you order data, how do you compare different values in there, so you can have that filter. Right here, I don't want to show everything. Here, just show, okay, give me the top 10. But what if I just want to get the top 10 of all the people that has a name that starts with K, right? So how do you do that? So we'll do that next week when we come back in our next meeting. Okay, I know it just went a kind of like really fast because we're not doing any of this coding yet. So I want to show you what's coming up next week. And if you want to reach chapter 2 and get your server installed, okay, and also make sure that they have the VDI working just in case. And we should get right into the coding for next week. And if you run into any issues with the server at all, please let me know. I'm more happy to assist. And I want to make sure you have a functioning, a working system to work with. Okay? Any other questions before we dismiss today? We're good?